All right, so today we're going to start trigonometry. In order to do trigonometry, you need to be able to do some other things first. One of those things is to solve proportions where one side it looks like just a whole number, where it's not written as a fraction. It's really pretty easy, but we're going to go ahead and do it real quickly. So solve each of the following to the nearest hundredth. Let's talk about place value for just a second. So if you've got a number and then a decimal place, what's the first number after the decimal? Tenths. And the next one? Hundredths, excuse me. And the next one after that? Thousandths. That's as far as we're going to go in this class. I won't ever ask you to round something to the nearest 10,000th, but some problems will say hundredths, some problems will say tenths, some will say thousandths. You got to be able to round them to the correct value. Remember that when you're rounding to the nearest hundredth, you look at the number after that. If it's 5 or larger, you add 1 to the hundredths place. If it's less than 5, you just drop those numbers off. Okay, so let's do this. So for this particular one, it makes it a lot easier if, although this doesn't look like a fraction, what is 18 as a fraction? 18 over 1. So we'll cross multiply. 1 times x is x. 18 times 11, well, you can use your calculator for it, but it's 198. Okay, this is the easiest kind, and you will have a few like this to practice, where what's across from the variable is just a 1. But it's not always that way. Take, for example, this problem. You got 34 equals 87 over x. Put this over 1. Do the cross multiplication. We get 87 is equal to 34x. Then to solve that, what will we do? Yeah, actually we'll divide both sides by 34. And 34 divided by 34 is what? 1. So we just have 1x. And then I've been doing statistics on this. Got to wake it up and clear all that out. So we're going to have 87 divided by 34. We want to round this to the nearest hundredth. So we'll look at the place behind the hundredths place, which is an 8. So what are we going to do to the 5 in front of it? It's going to be 6. So this is going to be 2.56. Okay? And I'm, for those of you who are like, why is he doing this? Because you're going to have to be able to do this in the trig problems. And I'm really not trying to insult your intelligence. Okay? Some of you are like, man, this is crazy easy stuff. I know. All right. What about a problem like this with a square root in it? No need to freak out. It works out pretty nicely. We'll again put this over 1. And then we'll cross multiply. 1 times x is just going to be x. And 9 times the square root of 73 is 9 square roots of 73. That, by the way, is the exact answer. This is the exact, perfect, nothing wrong with it, correct to every decimal place answer. But they asked us to approximate our answers to the nearest, hundredth? So we'll do this on our calculator. That's 9. And you don't even have to put the times, but you can. Square root 73. We'll look at the number after the hundredths place. So we're going to add 1 to the 9. So this is going to be 76 point what? Yeah. And it's important that you keep the 0. When it says round to the nearest hundredth, if you've rounded at all, you need to have something in the hundredths place. Now, if you haven't had to round, you know, if it came out to be the answer to this was 3.5, well, you just write 3.5. Okay, you don't have to put a 0, but if you have rounded, you need to have the hundredths place. All right. So now let's look at this part. Again, we're going to cross multiply after we put this over 1. So we cross multiply and we have 43 is equal to the square root of 127 times x. To solve that, what will we do?
Divide by the square root of 127.
Yeah, divide both sides by the square root of 127. Again, that is the exact answer. The exact answer is 43 over the square root of 127. But not a particularly, pretty answer if you're going to, I don't know, you're out buying fence or something. You're like, how much fence do you need? I need 43 over the square root of 127 feet. They're going to laugh at you. Okay? And no one likes to be laughed at. So we'll do 43 divided by the square root of 127. Morrissey, you with us? You have people that are plotting how they're going to wake you up. So again, since this is a 5, we'll add 1, so that'll be 3.82 is our approximation for x. Everybody good with that? And again, I'm hoping that most of you are like, this is really easy. That's if it's not, then you need to practice, but hopefully you think it's really easy. All right, so let's take a look at these last two problems. We have x squared is equal to 423 over 18. Well, we could put it over 1 and cross multiply, but then you're going to just turn right back around and divide. I'm trying to get the x by itself. How do I get rid of the squared? Take the square root. And when we take the square root, you should always take both the positive and the negative square root. So when you have a squared term, you can get two different answers. Again, this is the exact answer, plus or minus the square root of 423 over 18. But I'd like a decimal approximation for that. So I'll do the square root of 423 divided by 18. So to the nearest hundredth, this is going to be plus or minus 4.85. Somehow or another, I've ended up with all ones that rounded up. Now, could you do 423 divided by 18 first and then take the square root? Yeah, but I think it's a waste of time. I always do the math to solve for the variable first and then put it into my calculator one time. Some students are like, yeah, I do this and then I do a little more on my paper, and then I do this on the calculator, do a little more on my paper. I'm like, I can't be bothered to do that. All right, last one on this page, we have the square root of x is equal to 34 over 110. How do we get x by itself here?
Square.
We square both sides. because squaring is the opposite or inverse operation of taking the square root. So grab the calculator and we'll do 34 divided by 110. Be sure that that's in parentheses. Otherwise, it's just going to square the 110. And x is 0.10. Somehow or another, randomly picking numbers, I got everything we did rounded up. It won't always be that way. All right, page 2. That's all getting ready to solve trig things. So trigonometry all comes from similarity, or at least the basis of trigonometry that we're going to do all comes from similarity. So my question here is, why are triangle ABC and XYZ similar? What method could I use to prove those two triangles similar? Yep, it's angle-angle similarity. The right angles are congruent. I've got two angles that are 23 degrees that are both going to be congruent. All right. So if I do AB over XY then equals BC over what? YZ. There we're just matching up the corresponding pieces, right? But then what if I wanted to go AB to BC? What do you think I should do for the second ratio? Yeah, it should be XY to YZ. Why? Because I want the same cross products as I had before. The cross products here were AB times YZ. Here I have AB times YZ. It's the same cross products. So notice that in both of these, you don't need to draw that, where are AB and XY in relationship to the 23-degree angle? They are opposite it. They're all the way across the triangle from it. And what are BC and YZ in their respective triangles? They are the hypotenuse in each of their respective triangles. Does it matter that this triangle is a lot smaller than this triangle? No. These ratios are going to be the same. So it turns out that for any right triangle with a 23-degree angle, the ratio of the side across from the 23-degree angle to the hypotenuse is going to be the same. This is the basis for trigonometry. So the ratio of the side opposite an acute angle to the hypotenuse is so incredibly useful that it has a name, and it is called sine, S-I-N-E, not S-I-G-N, S-I-N-E. And there's a really long story that I will not tell you about how it shouldn't be sine. It got screwed up when it got translated from Arabic to Latin, and then when it got changed to English, they kept it. They didn't realize it had been messed up, and by the time someone realized that they had messed up the translation, it was about 200 years later, and people were like, yeah, we're not fixing that. So it really shouldn't be sine, but that's another very long story that I won't tell you. All right, here are the definitions for the 3 out of the 6. We're only learning half of them. We will never learn the other half. You'll learn the other half when you get to pre-cal. Trigonometric functions. You must memorize these. If you do not memorize these, you will fail the test. Okay? You can't do this next test without memorizing this. And we'll talk about some ways to help you memorize them in just a second. But First of all, notice it has to be in a right triangle. If it's not in a right triangle, none of these rules apply. Just like, what's the other thing that only applies to right triangles? Pythagorean theorem only applies to right triangles. Okay? The triangles, the trigonometry that we're learning, some books call it right triangle trigonometry. It only applies to right triangles. And angle A has to be acute. It cannot be the right angle. It has to be one of the two acute angles. It doesn't matter which.
How do you know which one is angle A?
Pardon?
How do you know which one is angle A?
Because you'll have, in the problem, you'll have a diagram or it will tell you about the angles.
Oh, okay.
And it doesn't matter, A is just an arbitrary. It could be X, it could be Z, it could be whatever. But it's got to be an acute angle. Okay? So the long way to write it out is this way. The sine of angle A is the leg opposite angle A over the hypotenuse. The shorthand for that is to write it this way. All of the trig functions can be abbreviated with 3 letters. So they'll write it out this way. You'll still say it the same way though. The sine of A is equal to the opposite over the hypotenuse. Please, 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 don't be stupid and say the sin of A. A didn't do anything wrong. A is not bad. A is not going to hell. It did not commit any sins. It's the sine of A. It's an abbreviation. So please don't say the sin of A. Okay? It's sine of A is opposite over hypotenuse. The cosine of angle A is the leg adjacent to angle A over the hypotenuse. Again, we'll shorthand that by saying cosine of A, and again, don't say the cos of A. There's no such thing as cos. The cos of A, you'll say the cosine of A. Cosine of A is equal to adjacent over hypotenuse. And in both of these, you have to know that the opposite, you mean the leg, and adjacent, you mean a leg. That's important. And then finally, the tangent of angle A is the leg opposite angle A to the leg adjacent to angle A. So the tangent of A is opposite over adjacent. So, how hard is this to memorize? Well, frankly, it's not very hard at all. If you'll just say it a few times, and actually, let's say it all together once. I will lead you through it, and then I'll have you guys say it. So, I'll say it first, I'll do it with you, and then you guys will do it. So, you'll say the sine of A is equal to the opposite over the hypotenuse. The cosine of A is equal to the adjacent over the hypotenuse. And the tangent of A is equal to the opposite over adjacent. So everybody says it with me. If you don't say it with me, I'll make you stand up and say it by yourself. I already see the people who are looking at me going, I'm not saying that. Okay. You can say it with the group or you can say it by yourself. Them are your choices. So everybody together. Ready? The sine of A is equal to the opposite over the hypotenuse. The cosine of A is equal to the adjacent over the hypotenuse. And the tangent of A is the opposite over the adjacent. And now just you guys. Ready? The sine. Slow down. Wow, that was the worst everybody I think I've ever heard out of a group. Man.
We have a rhythm, that's why. Nothing.
Yeah, some people have no rhythm. It's a little bit like when you're doing the pledge to the flag. Some people are done in 2 seconds and other people are like, is it indivisible? Yeah. So there are lots of ways to memorize this. I think it's not so hard that you need one of these crutches to memorize it, but for those of you who think you need a crutch, I'm going to give you not one, but 2. Again, I hate these because this is not hard to memorize. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. That's all you need to know. That takes, less than 10 seconds to say the whole thing. But if you're one of those people who likes things like this and you find them helpful, that's okay. The first one is to memorize the made-up word Sohcahtoa, which stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Why don't I like this? Because I swear to you, I had a student in the middle of a test years ago raise their hand and go, I forgot how to spell Sohcahtoa. I'm like, well, it sucks being you then. Okay? If you're going to use this, you have to know how to spell it. Otherwise, it doesn't help you. Okay? You can also memorize a sentence. You may have done this like, there's a sentence for the order of the planets. I don't know what it is. Or what's the one in biology where it's kingdom, phylum, whatever?
King David came over for grapes. I think. Pretty sure. The one we learned was something about giant shrimp.
So there's a famous one for this, and I'll apologize for the drug reference in advance. Some old hippie caught another hippie tripping on acid. I don't know who came up with this one first. I will say that either my second or third year teaching, I had a group that I told this to, and they're like, we want to make up our own. And I was like, okay. And what they came up with was this one, another drug reference. Spiders on heroin can always hallucinate till others arrive. And I'm like, yeah, I remember this, and this has been a long time ago. This would have been like the late 80s.
So it worked.
So it stuck with me. Yeah. However you memorize this, whether it's using Sohcahtoa or just memorizing or using a sentence, that's up to you, but you got to memorize these. If you don't have them memorized, or if you have them memorized incorrectly, you will fail the test. There's no two ways about it. Because about a third of the problems will be sine, about a third will be cosine, and about a third will be tangent. So if you have one of them wrong, you probably have another one wrong, which means your high score is probably about a 35. Okay? If you have them memorized, well, then your upside is much higher. Yes, sir?
What about cosine?
There are three other trig functions that we are not going to mess with. Secant, cosecant, and cotangent. We will not do anything with those. We don't need them. For what we're doing, we're not going to use them. Okay? All right. So, what are we going to do with these? Well, for right now, all we're going to do is write the ratio. So, if I want the sine of R, notice R is one of the acute angles. So, the sine of R. Sine is what over what? Opposite over hypotenuse. So from R, which leg is opposite?
T.
12. You could say ST or you could say 12. And what's the length of the side of the hypotenuse? 13. That's all we're going to do with it. Don't give me a decimal. Don't do anything else with it. Just do that for right now. Okay? What will the cosine of R be? Cosine is what over what?
Adjacent over hypotenuse.
Adjacent over hypotenuse. And be careful on that one when it says adjacent. What does adjacent mean?
Right next.
Adjacent means right next to. It's the adjacent leg. So if I'm at angle R, the leg that's adjacent to that is 5. 12 is the leg that's opposite it. So that's going to be 5 over the hypotenuse is still 13. And the tangent of R is opposite over adjacent. So the opposite from R all the way across the triangle, that's 12. Over the adjacent leg, 5. And then we're going to do the same thing with angle T. The sine of angle T, sine is what over what? Opposite over hypotenuse. So from T, what leg is opposite? 5. Over the hypotenuse, 13. The cosine of T, this time I want the adjacent leg over the hypotenuse. So that's going to be what over what? 12 over 13. And tangent is the opposite leg over the adjacent leg. It's 5 over 12. Okay, any questions about that? We can also do this based on the angles measure.
We can't do that for S because it's not right.
Exactly right. We can't say the sine or the cosine or the tangent of S based on these rules. Now, again, when you get to pre-cal, you'll find that a right angle does have a sine and a cosine and a tangent, but don't worry about it right now. Okay, so the sine of the angle that's 26, sine is what over what? Opposite over hypotenuse. Very nice. So from the 26, what's opposite? X. And the hypotenuse? 17. And before we go on to the next one, I'm just going to point out that what we're going to be doing starting on Friday is we'll be solving that for x using your calculator. Okay, which is why it's important that you can solve proportions. All right, tangent of 64. Tangent is what over what? Opposite over adjacent. So from the 64, what's the opposite leg?
9.
9. And what's the adjacent leg?
X.
X. All right, the tangent of 26. Opposite over adjacent again. From the 26, what's the opposite? X. And what's the adjacent? 9. Notice that's just the reciprocal of the previous one. That's always going to be true for tangents of these two angles. Cosine of 26. Cosine is what over what?
Adjacent over hypotenuse.
Adjacent over hypotenuse. That's 9 over 17. The sine of 64. Sine is what over what? Opposite over hypotenuse. That's 9 over 17. And last but not least, the cosine of 64. Cosine is what over what? Adjacent over hypotenuse. The adjacent leg is? X. And the hypotenuse is still 17. All right, I'm going to go ahead and give you the worksheet that will be due on Friday. You can go ahead and put it away, and then I'm going to give you